This is my industrial robot, and I've been using it as a CNC machine to create projects like this. But ever since I've got the robot, I wanted to try to 3D print with it, so that's what we're going to try. We start with the mechanical design of the extruder and spool holder. These will be printed with regular PLA filament. For this test, I'm going to use a Creality Sprite Pro direct drive extruder with a 1mm nozzle. Because the robot's memory is too small, I've created a program that converts G-code to ABB rapid code and then sends this to the S4C controller line by line over serial. A link to the program can be found in the description below. With the hardware and software finished, we can now do a first test print. I'm using a ramps board running Marlin to control the extruder. The ramps board is a bit outdated, but it's good enough for this test setup. The hardest part was to sync up the robot's movements with the extruder, mainly because they each have their own motion planner. I also had to send the X, Y, Z values to the extruder as well, instead of only the extruder feed values. This was necessary for the motion planner to calculate the correct feed rate for the extruder. And after playing around with the speeds, feeds and accelerations, we got some decent results. So now it's time to print something bigger. That worked pretty well. Now let's test it on a more detailed model. And for that, we're going to use the MetroY Pro 3D scanner, which was kindly sent to me by RevoPoint. As a first test, we're going to use our bench test model, which is Wally. The turntable allows for a completely automated way to 3D scan smaller objects. Multiple scans from different angles can be taken from the object. These can then be later merged together to create a complete model. And the result we get looks amazing. Here, we can see the 3D printed copy compared to the original. Now it's time to test it on a larger and more detailed model. This is the Pietà, which is sculpted by my grandfather, all by himself. He spent almost 3 years carving this sculpture by hand out of a 3-ton marble stone. This is the perfect test subject for the 3D scanner. Using the parallel lines option, we can capture all the smallest details of the sculpture. After the scanning is completed, we can once again combine multiple scans to create a complete model. This is all done inside the RevoMetro software. Some repair of the model is needed in Mesh Mixer to fill the areas we were not able to reach with the scanner. And this is the result we get. A link to this 3D model can be found in the description. With the model finished, we can now print it with the robot. If we compare the print of the robot with the one of a normal, commercially available 3D printer, we can see that there is some room for improvement, but this is already a good start. The main issue I'm having now with this setup is that the robot is struggling with the large amounts of points, positioned close together, generated by the slicer software. This can be partially solved by simplifying the model beforehand. And this is no issue at all with simpler models, like the Vase model. Overall, I'm quite happy with the result we managed to get out of this 26-year-old robot. And I'm sure that with some more tweaking, we can improve the print quality by a lot in the future. All the info about this project can be found in the description. Thanks for watching, and I'll see you in the next video.